All right, guys, welcome to Algebra 2 for April 3rd. We are going to go over the two problems that I mentioned at the end of the video yesterday that you could try out and that we would check today. So that's really going to be our primary goal today, is just solving these two, and then we'll move on to the next part of this section on Monday. So on number 5, starting here, we are going to combine like terms in our numerator, and then our denominator is going to stay exactly the same. So we have n squared, 3n minus n is going to give us 2n, and then we have negative 7 minus 1, so that's going to be minus 8. And then that's going to be over, remember here, the denominators stay exactly the same, n squared plus n minus 6. Now what I want to do is go ahead and factor the numerator and denominator, cancel out what I can. So I'm going to do that. The numerator we can box method. It will simplify down to, let's see, n is our variable. So n plus 4, n minus 2. Again, if you ever have questions about the box method, there's a video on the Google Classroom from about a week ago that is explicitly just for box method solving. Then right here, we are going to box method the denominator. We get n plus 3 and n minus 2. What we see is that we have some similarities or some identical binomials in the numerator and denominator that we can cancel out, and we are left with just n plus 4 over n plus 3 as our final answer. And that is that. We'll go ahead and take a look at number 6 here as well. It's going to be the same idea, we just have a couple larger numbers. So in the numerator, we have 13k squared plus k squared. That is going to give us 14k squared. Then we have minus 9k plus 2k. So negative 9 plus 2 is going to give us negative 7, and I just have k with them. The denominator again is going to stay the same, 6k squared minus 5k plus 1. We're going to go ahead and simplify the numerator. Now, anytime you look at any of these terms, the numerators or denominators, you want to ask yourself, can you factor it out? That's the first question. And in this case, that answer is yes. 14k squared and 7k both have 7k in common, meaning this is going to be left as 2k, and then this is going to be left as minus 1, just like that, because we're dividing the whole thing out. The denominator doesn't have anything in common right off the bat, so we are going to have to box method it. Now, once you box method it, I'm going to go ahead and do that right above here since it has some coefficients. I just want to make sure I'm doing it correctly. So we get 6k squared in the first box, 1 in the last one. They multiply. We need factors of 6 that add to negative 5. That's going to be negative 3k, negative 2k, minus, minus, and we have 2k in common. We have a 1. Here we have a 3k, and we have a 1. So we're going to get 3k minus 1 and 2k minus 1. Now, what we'll see is that we again have some redundancies in the numerator and denominator, which can cancel out, just like this. And we are left with 7k over 3k minus 1. Now, some of you may be thinking, can we cancel out this k and that k? The answer to that question is no, because it's always important to recall, and I know you've heard me say it 100 times now, but we always got to make sure we remember that if something is part of an addition or subtraction expression, or a binomial, whatever you want to think of it as, if there's addition or subtraction happening with it, then you have to cancel out everything there, meaning everything has to be identical, not just one term. So we cannot cancel out this k and this k. because the denominator one has some subtraction happening with it. That's how we get our answers for 5 and 6. If you have any questions about those, email me. If you have any questions about what we've done so far in this section with adding and subtracting these, feel free to email me. Next Monday, we are going to start doing the problems right down here that have denominators that are not the same. Terrifying, I know. But we'll jump into that next week. So, again, if you have any questions, shoot me an email. Otherwise, see you guys Monday.